All right, I just want to give you a quick rundown of the answers so that you can check your work that you may have done. You're going to look for the length of the carbon. So there's 2, that's eth, right? ETH. And it's got double bonds, so that's going to be ethene. And the last thing you always have to do is put the number where the carbon is that starts the double bond. So you're starting from the left, that's going to be the first carbon. Here, you got 3 carbons, that's prop, and it's got a double bond, so propene. After the first carbon, so that's going to also be 1 propene. You wouldn't need it because wherever you put it, it's still going to be 1 propene. If you start from the other side, you just start counting on that side. Here, there's only 1 place for it. Now, 4 carbons is bute, and you have an ene, but there's 2 of them. Just like you had 2 oxygens and carbon dioxide, this is going to be 2 enes, so that's diene. And notice there's 2 consonants real close. So sometimes if there's like a T or something, a P, that's a hard consonant, that's they put an A between them just to make it a little bit more butadiene. Now, in that, you have to still say, where does the double bond start? One starts at the first carbon, one starts at the third carbon, and you always put dashes between numbers and letters. Okay, here's a 2 butene. Okay, again, you have 2 double bonds, so that's bute, because there's 4 carbons, and 2 enes, diene. Where do they start? At the first and third carbon, so it's the exact same one as this, but notice it just looks like there's different places for hydrogens. It isn't, it's just flipped over. Okay. Again, this one's a butene, just 1 double bond, butene. But it can start, it looks like it'd be the third. If you wrote 3, I would accept that for today. But really, you should start counting it from this side, because there's 1, there's 2. So it's after the first carbon, it should be 1 butene. Okay, so for today, that's fine that you may have, gotten an answer. If you put 3 butene, that's fine. But literally start counting from the other side to give it the lowest numbers. 1 propene. This one's just propane because there's no double bond, so it just ends in ane. Okay, here you have a triple bond, so that's still 2 carbons. That's eth, and the triple bond ending is ine, ethine, Y-N-E, and you still should put the 1 in there to tell where it starts. Now, that's the naming. You just find the longest chain of carbons without backtracking, and you give that parent chain based on the number of carbons, and then tell me if it's got a double or triple bond in it. Let's take a look at these last ones. Propene. Look at the starting word here. That's going to tell you how many carbons is in that. So 1, 2, 3 for 3 carbons. And it's got a double bond, so it's got to be here. Now, you could put it the other side again. It's not 1 in front, although it should be. If you did it every time, you'd get way less wrong than if you got messed up and didn't put your numbers in. And then what you got to do is count up how many sticks are coming off that carbon. Because there's 2 going in the middle, it's still got room for 2 more, or 8 electrons. Remember the octet rule? Carbon wants to have 8 around it. So 2 of them have to be added, and those go to hydrogens. So anything that's not mentioned just is going to be extra hydrogens. This says 1, 2, 3. You know what, I'll do this so that you can see it a little better on that film. That's supposed to be 2. Okay? And that is a double bond. So there's the third bond. It has room for 1 more hydrogen. This carbon, if you just look and say, oh, there's only 1 stick coming off it, so there's room for 3 more. Okay, that's how you find out how many each of these hydrogens it has. And then I want you to count up the carbons and say, oh, there's 3 of those. And how many hydrogens? 1, 2, 3, 4, 5, 6. Okay. If you remember before that, it was always double the number of carbons plus 2 for hydrogens that we talked about in class. If you put a double bond, that's going to take 2 of those away. It's just double the number of carbons is the hydrogens. Pentadiene. 1, 2, 3, 4, 5. Okay, and then it's got 2 enes, 1 after the first, 1 after the second. This already has 2, so it's got room for 2 hydrogens. This has got 4 off it, so can't put any more. This has 3, so that has room for 1 more hydrogen. This has room for 2 hydrogens. And this last one has room for 3 hydrogens. Okay. Now, since it has 2 enes, that's going to be 4 less hydrogens off of it. So you double plus 2, so 5 C5. Normally, I would have said that has 12 hydrogens because it's double plus 2. Since I have 2 double bonds, I'm going to take 2 off for every double bond. So that's going to be actually double plus 2, but I got to take back 4. So this is going to be double minus 2. So that's going to be 8, C8H8. And I wouldn't have expected you to see that pattern. I just want to point it out. You're going to count them up and you're going to be fine. Okay, heptine is 1, 2, 3, 4, 5, 6, 7. Okay, double bond after the third carbon. So this has room for 2, this has room for 2, this has only room for 1, that has room for 1, this has room for 2, 2, and then 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C7H12. So that takes every, oops, and it's a triple bond, that's why. Oops, so that's going to actually goof this up. So where this crazy yellow thing is, I'm going to actually write these in. Let's write those in and get that rolling. It's going to now sit and think a second. I can't put any there, so you can actually see these. So that's triple bond. There shouldn't be anything here. Okay, so now I have C, 1, 2, 3, 4, 5, 6, 7, and H's. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Heptine. Because it's a heptine, it's double minus 2. Double minus 2. I didn't count those. 2, 4, 6. Oh, I forgot one up here. 6, 8, 10, 11. And I must be missing one somewhere. Oh, down here. 12. Okay? Now, you may say, what's all this doubling ene things? But it's still got this as the parent chain. So 4 carbons. 1, 2, 3, 4. It has an ine group right after the first carbon. That means a triple bond. It has an ene group after the third carbon. So 1, 2, 3. This is the ene. That's the double bond, the third carbon right here. Now, I just want to figure out how many hydrogens it has. This has 3, so it's got room for 1 more. This one's got 4, so there's no room for another stick. This has 3, so it has room for 1 more hydrogen. And this one has 2, so it's got room for 2 hydrogens. Okay. Hexadiene means 6 carbons. 2, 3, 4, 5, 6. 1, 2, 3. Let's put single bonds in there all over. I got a double bond after the first and a double bond after the third. So that's got room for 2. This has room for 1. Here has room for 1. This has room for 1. That has room for 2. Up and over. So I can count those out. Okay, so I have a total of C6, 2, 4, 6, 8, 10, H10. Okay, octane's the last one. You got 8 carbons, 3, 4, 5, 6, 7, 8. All of them have hydrogens all around, so this is a double, C8. Double that number plus 2, so that's CH18. I'm just going to put the sticks on so that you see those. Okay. Awesome. So that's that assignment. Okay, that hopefully gets you the answers, and I'll ask you how many you got right or wrong on Tuesday.